This is my final project for the physics class, and it's a reaction time for human beings using a sample of 5 males and 5 female, and this is Ishrat Budu here. And we used material that the professor gave us, that is a small strip, and to do that we scale the strip with every 5 millimeter. And to get the reaction time, we use the kinematic equation y is equal to y naught plus vy naught t plus half ayt square, whereby vy naught is equal to 0 and the acceleration is the pull of gravity, which is 9.8 meter per second square. And we obtain the reaction time for each increment in displacement of 5 millimeter for the RD strip. To do that, we compute on Excel using the formula given, and so on, and so we get the reaction time for each displacement. And at the end, we make a graph. We get the graph of the distance of the reaction time and according to the distance, which is an upward sloping curve. And when we do the experiment with the 5 males and 5 females, those are the data that we get. And as we can see, the male have a faster reaction time than the female. This one is with extraneous stimuli, that is the subjects are being distracted while conducting the experiment, and so they're not really focused when the reaction strip falls down, and so they have a slower reaction time. They react slower for grabbing the reaction strip when it falls down. And according to the mean calculated on the 10 subjects, we can analyze with extraneous stimuli and without extraneous stimuli, is that the males still have a faster reaction time than the female. And the standard deviation of these subjects are rather small, and therefore the raw data they are really close to each other. They have a sample have a small range of difference in their reaction times. There is no outliers. And the difference in the reaction time for each subject between stimuli and non-stimuli, it varies between 13 to 27 for the male, and 19 to approximately 36 for the females. Now for the second improved reaction strip, we use the paper that the professor gave us, and we fold it into a long strip which is about 85 centimeter long. Again, we scale it every 5 millimeter, but for this reaction strip we will use a cardboard shield to hide the reaction strip from the subject, and when it falls down it will already have an initial velocity, and the subjects will only see the reaction strip when it passes past the cardboard. And we use a distance of 150 millimeter high before dropping the reaction strip. And again we will use the equation, the kinematic equation, where y is equal to y naught plus vy naught t plus half ayt square. To solve for t, we will get a quadratic equation for the time, and of course we will discard the time with a negative value. And the vy naught will have a value of square root of 2 times gravity times the distance, And so we will get a equation whereby time is equal to square root of the 2 times distance divided by gravity plus the square root of 2 divided by gravity times the distance plus the displacement, the change in displacement. And we computed in the Excel sheet the formula with the distance every 5 millimeter, and we'll get the reaction time for each of this displacement. And so we can scale down our reaction strip with the reaction time. And again, using the 5 males and the 5 females corresponding, we get a second result for the second reaction strip. And still, the males have a faster reaction time than the females. And now this is a computation of reaction time of subjects using the second order strip, but with external stimuli. Both the male and the female have a slower reaction time than the first experiment without any stimuli. But again, in the majority, the male have a faster reaction time than the females. The mean computed and the standard deviation. Still, the mean of the average of the male is smaller than the average of the females. If going only according by the mean and the raw data collected, the males still have a faster reaction time than the females. And the standard deviation is not that high, so again, the sample from the sample taken, there are no exactly outliers, and each and every one have a pretty close reaction time to each other. This is the difference between the subjects when they have stimuli and when they don't have any stimuli. This one range a bit higher than the first range. For the male, it ranged from approximately 34 to 61, and the female varies from 51 to 68. This one a bit higher than the first range. And in conclusion, well, with extraneous stimuli, it is clearly that it does make a difference for when the subjects are subjected with extraneous stimuli, and that is to say that they are distracted and they are not focused, and so it takes a longer time for their brain to react and send the message for the hand to grasp the reaction strip, and therefore, and in that case, it's both the male and the females that take more time to react and when they are being distracted. And now the reaction times of males versus females when there is no extraneous stimuli, well, based on data collected and from the mean calculated from the 5 males and 5 females, for both reaction strip, for the first one and the second one, the males have a faster reaction time than the female. And with extraneous stimuli, it has the same result. The male reacts faster than the females. And this has a bearing on cell phone while driving, because we can use the same experiment to explain that, because when you're driving and you are using your cell phone, your mind is on the cell phone and not focused on the road, and therefore if ever there is something ahead on the road and you have to brake, it will take you a longer time to react and put your foot on the brake, and so this can lead to accidents because you take more time to react. That is, your mind cannot do two works at the same time. And so you have to choose between either using your phone or driving, and this can be really dangerous if you do both at the same time. So an advice, don't use cell phones while driving. And that's it. Thank you.